Welcome to this session, which will talk about the challenges and opportunities for residential decarbonization. My name is Arand Casas. I'm an energy technology researcher at LBNL, and I will be moderating the session. Decarbonizing the U.S. residential building stock is a huge undertaking, but necessary for us to meet our federal climate goals. There are approximately 118 million homes in the U.S., and in order to succeed, solutions need to be developed for all households, which may vary in climate zone, income, and ownership status. Decarbonization must be equitable, affordable, and accessible. And finally, this effort must support the U.S.'s transition to a clean energy economy by empowering the workforce of tomorrow. We have the pleasure of welcoming Dr. Ian Walker today to discuss DOE's work in characterizing these challenges and opportunities that await us in this undertaking. Dr. Ian Walker is a scientist at Lawrence Berkeley National Laboratory. He has more than 30 years of experience as a building scientist, and his current work focuses on residential ventilation and home decarbonization. So Ian, please, whenever you're ready.
Thank you, Armando. Yeah, so I think Armando made a great point that I will start out with here, which is the pressure behind this is we really need to get to scale. There's a few homes in the country that have decarbonized, but not many. And this is a big thing for DOE, is their objective is to really push the residential sector in terms of its carbon savings. And so we've recently published a report. You can see the cover of it here. You can see the DOI for it. It's available free. When you get these slides, you can look it up. I'm going to sort of give a very high level overview of what's in this report and touch on a few of these ideas, because really we need to identify, what are the barriers to getting to scale and what are some possible solutions, and we'll touch on that over the next 20 minutes or so. And think about what are some of the challenges and opportunities, and that means homeowners, utilities, program managers, they all have different challenges and opportunities, and we'll touch on a few of those as we go along here. There were effectively three different types of challenge that we are facing here. There's technical things like, can you find the right products to actually electrify a home? And broadly, I'm going to answer that question and say yes, and I'll talk a little bit more about some of those details later. The next thing is about affordability. How do we do this in a way that is affordable? And there's a lot of focus there on things like cost reductions. And finally, there are ideas about how do we value what we are doing? Almost everything you do to somebody's home is an investment in that home. It can change its value. There are all sorts of non-energy benefits about comfort and health and so on. And so we can't do these things in isolation. We have to consider all these things together. And the US DOE has several priorities in this area. They want to emphasize that we have to develop solutions that work for all households. That includes all housing types, multifamily buildings, single-family buildings, high-rise, low-rise, different kinds of occupancy, whether you're renting or not, ownership models like HOAs, people who have access to capital, people who don't. We need to find ways to address all households. And touching on the cost affordability again, we need to make these things easy and affordable. Right now, if you want to electrify a home that's all gas, it costs something like $50,000. And that's if you can find someone to come to your house, because we have just not enough plumbers, electricians, and contractors working in this area. And there's also all sorts of regulatory issues, which we'll touch on a little bit as well. And finally, sort of a big picture thing from DOE is this idea that we're trying to transition to effectively a green energy economy. So we'll talk a little bit about how businesses can be engaged in this and things like, how can we be kind to the grid? We probably don't have the time and the resources to completely replace the electric grid. So how do we accomplish what we need to do while avoiding that? So I'll jump straight into some of the technical issues. For example, there's this concept that we're going to call low power electrification that looks at things like how close are our homes to, the total panel capacity? Do they actually have enough space in terms of the number of breakers and the amps available to electrify? And what if they use power efficient appliances? Would that help? What about technologies like circuit sharing and energy storage? How do they influence these things? And really here, I think we want to focus on the large loads, that is heating, cooling, hot water, clothes drying. Cooking, of course, and clothes drying are less energy use than heating, cooling, and hot water. And so maybe less interesting from a carbon and emissions point of view. But then we have things that really interact heavily, both from a power in a home perspective and from a carbon perspective. And that is electrifying our transportation with EV and putting solar panels on our roof. Both of those things substantially change what's happening electrically in a home. And there are already folks out there sort of doing the good work here. I've given one example, which is the watt diet calculator from our friends at Redwood Energy and Tom Cabot. They sort of step-by-step take you through a whole bunch of these issues to try and simplify it. And one of the things I mentioned here was this idea of power efficient appliances. And what do we mean by that? Basically, what we're talking about is we want to not use the traditional very high power in terms of what 240-volt appliances. They mean that you're going to do things that really will require a lot of investment in new infrastructure, both in the home and for the grid electrically. And we're also thinking about things that could be done effectively as a DIY solution, which is, of course, good for renters and helps us with some of our lack of workforce issues. And there's just a few examples here of devices you can put in your home that are much, much less power than what we have used traditional things like 120-volt heat pump water heaters that draw at the most 1,000 watts, often less than that. Similarly, with low power window heat pumps and so on. These are all devices which wouldn't put any additional strain on your home, but still would provide heating, hot water, the ability to wash and dry your clothes, and all those things that we expect in a home. Another question is sort of again, this is taking a broader look. This is an analysis that was done on something like 22,000 homes here in California to try and figure out what is actually the state of the art here. Like, what do homes currently do in terms of their electricity consumption? And this is just showing that out of these 22,000 homes, the vast majority, their peak power any time in the year is going to be under 20 kilowatts. That's under 88 amps. So if you have a 100 amp panel, the vast majority of homes never reach that. Similarly, there's a lot of homes, about half the homes never go above about 7 kilowatts, which is what, to give you some sort of equivalence, that's what a typical level 2 car charger is. They never even go above that. And the point here is to say that there's already a lot of unused capacity in the home anyway for electrification of homes without doing things like panel upgrades and lots of other expensive things. So admittedly, this is just this one sample. It's a lot of homes, 22,000 homes. We're currently expanding this to do this nationally, getting data sets from other states and so on, but we don't have that analysis finished. I can tell you, though, in advance, that our results are the same no matter where we look in the country, that there's lots and lots of capacity to electrify in homes. Another issue is, so I want to add loads. How easy or hard is that? And the big question here is, if I add a heat pump, is that a problem? How much electric load am I actually adding? And it's surprisingly little. I'm showing some data here from about 10,000 homes in Vermont, where we have measured electric power before and after adding heat pumps. And we know the mean nameplate rating on these heat pumps was about 3.6 kilowatts. So you're thinking, well, that's the load I'm adding, right? If I'm doing an NEC calculation, if I'm an electrician, that's what I have to think about. What we found was that average peak power was only about 200 watts for a host of reasons. It seems nonsensical, right? But sometimes people were replacing electric resistance heat with a heat pump. And in the plot of the data there, those are the homes on the left-hand side of the plot where their peak demand went down substantially when they added a heat pump because they were already on electric resistance. At the other end of the scale, we do have homes that added a lot of peak demand. And I guess a challenge for us all in this is to figure out, so on average, we only add a small amount of power. But if you're running a program and you're trying to figure out, how do I make this work for all homes? The answer will be slightly different. And figuring out this balance between how do we get to the most homes, which implies we should maybe use the average, and how do we account for all homes, which implies we have to use the maximum, is going to be a challenge as we go on, I think. And lastly, another question we've been looking at with regard to heat pumps is, do heat pumps actually trigger panel replacements in homes very often? And the answer is surprisingly rare. Again, we have a relatively large data set of over 10,000 homes from California, where we found that less than 5% of homes that added a heat pump actually had to have their panel replaced. And some of this ties into the regulation that we have in the National Electric Code, which is frankly not particularly clear and not developed with home electrification in mind. We're currently developing new proposals for the NEC to help with that. And I'll talk about one of those here. This chart I'm showing is looking at a bunch of homes where we know the peak demand, and we know the sum of the connected loads in the home, which is what the NEC tends to use. And there's already an existing calculation in the NEC that does a similar thing to this. But one of the things we're proposing is to replace that with this new way of calculating how loads are represented by the red line in the chart there. And again, this is another illustration of it'll work almost all the time for most of the homes, but that's the nature of the NEC, right? It's not about perfection, it's about risk management. So this is the sort of thing that would allow us to add more loads more easily and avoid things like panel electrical upgrades. I have to say, though, that things like there are other regulatory things, like often local authorities are unprepared for this electrification of homes. And some places simply aren't allowing us to install circuit sharers or smart panel controls. Simply because it's something new. It's not specifically necessarily called out word for word in the NEC, but we're working on changing that. And this sort of work about electrifying homes and what we do to rebate them, it started to make us think about maybe there are different approaches. Currently, there are large rebates if you replace your electric panel. And that allows us to install all the high power devices we want and so on. But that has some really important effects on the grid. If we're allowing super high power, peak power consumption, utilities have to account for that by basically replacing all the infrastructure and new transformers, new wires, and so on. And all those costs get passed on to ratepayers. So that increases the cost that you see on your bill every month, simply because we've got to pay for all that infrastructure. And places like Palo Alto, for example, have already got this problem where they're already at capacity and they're not allowing any more home electrification because they've already installed a lot of oversized panels. And if they use their normal standard calculations, the electric wires in the city can't support any more electrification. And we need to avoid that as much as possible. And one suggestion is to say, well, we'll give you that rebate for panel upsides, but only if you followed these two parts of the NEC and demonstrated that you definitely need it. I've touched on some of these ideas before about maybe we should be rebating low power, high performance devices like heat pumps and 120 volt systems. We should be rebating, not upsizing the panel instead. We also need to think about non-energy benefits. I've pulled a few out here, thinking about functionality. A lot of homes are going to have more comfortable environments when they electrify. And certainly things like steady temperatures, and if we include things like air sealing and insulation when they do these things, that will definitely improve. There's all sorts of issue about health and safety, about not having no combustion in the house is an enormous indoor air quality issue. And there's been a lot of work done on that and what the public health and individual health benefits are. There's also some safety issues if you use an induction cooker, you have cooler surfaces. And beyond just sort of those indoor air quality things, there's also things like if you add a heat pump, you also get cooling for free. And we can reduce our heat stress problems as we have longer, hotter summers, for example. And other things that some businesses are already very successfully doing, and we'd like to see fold over more into other programs, is to emphasize value over cost. Although I will say some of this is kind of squishy. We don't really have a good handle on what happens to home value when you electrify. But we do know that thinking about things in terms of affordable comfort rather than return on investment is how households make decisions. Households do not make decisions the same way that businesses do, and we really need to recognize that. Having said all that, there's still a lot of scope to reduce the costs of what we're doing. I touched on avoiding things like panel utility service changes, which are many thousands of dollars in most homes. There are ideas if you're planning programs about bulk purchases that have been around for a while and simplified permitting. These are all not new ideas, but boy, do we need to push them hard. Upfront rebates rather than things like tax credits later turn out to be much more popular with homeowners, particularly low-income homeowners. People want to know what they're getting upfront. That sort of reduces the risk and the concern about doing these things to the homes. That's going to be super important. And there are questions about, should we remove legacy systems? It's costly to remove a furnace or asbestos covered ducts? Should we just leave them in place and leave them for later? And in the little panel there on the right-hand side, we're kind of summarizing some of these solutions for avoiding panel and service upgrades that include things like smart electric panels, which mean you probably don't need to change the service drop on the utility. Circuit sharing and circuit pausing, again, depending on where you live, you may or may not be allowed to do those things. And we're pushing to change that. And things like using meter collars, so you don't have to upgrade the panel, but could still add electric vehicle charger and PV. There's all sorts of technical things that are currently incredibly rare. All those things in that chart are very rare. They need to become commonplace. And lastly, the thing that is a real challenge when I talk to contractors who are doing this work is this problem of pre-existing conditions. I've listed a bunch here, but these have all long been challenges. For example, the DOE weatherization program has had to do with all of these for years. How much money are we willing to spend fixing all the problems in homes that are not directly related to, say, installing a heat pump, but probably need to be addressed? And it's unclear what we do with that. I want to move on now to thinking about how to get to scale. This really, really needs to work for businesses. And one of the things we found is that there's very high overhead in energy upgrades compared to new construction and general residential remodeling. And this is just showing some of those data. And we need to try and fix that somehow. And this is just sort of what I call the circle of doom we're currently trapped in, where high costs lead to lack of customer demand, which means it takes a lot of effort for contractors to get contracts signed. That's a bunch of overhead, which bleeds into high costs, and we go round and round. And some of these ideas I've been talking about here today are in the little boxes on the perimeter, where we're trying to sort of inject ideas and solutions into this circle to bring down these costs. And the last couple of things I want to talk about are related to equity and some other things DOE are doing. There's a whole bunch of issues regarding we need to keep things really simple. There's a lot of concern in the rental market about if you have to vacate your home because there's a huge upgrade being to it and they're opening walls to install wires and so on. Will you get back into your home? Where do you live in the meanwhile? Will your rent go up? There's all sorts of issues connected to the rental market that we need to deal with, probably through regulation. There's other regulatory things about rebates and tax credits and what to do about net metering for solar PV and so on. That are, again, things that we need to start thinking about if we're going to get to scale. And lastly, there's issues that have got to do with what do we do about if people's bills go up or down? Now, most of the time, there's going to be significant cost savings when we do this, but not always. And the little chart on the right there is showing a bunch of bubbles of different states. The bubbles are sort of scaled by the number of gas appliances in each state. And positive cost savings is showing that in most states, there are cost savings, but if you're to the left of that line, it's possible your bill could go up and we would need to do other things like cost control measures. And vertically, though, it shows that our CO2 savings for electrification are significant. And these bubbles are drifting up at a few percent a year as we improve the grid. And this is from 2019. And I can tell you, we've shifted upwards and onwards in the last 3 years. So far fewer homes are going to have increases in bills and far more homes are going to see large CO2 savings. And the last thing I want to talk about is there's a few other DOE efforts, not just the R&D being done at the national labs. And I want to give one quick example, which is the Easy Home Electrification Prize. It's just had its round one. It was last year. We're going to do another round in the coming year, which is to find solutions for hard to electrify homes and things like cold climates, homes that are very gassy, like in my home state of California, my own personal home, what do multifamily homes and so on, and historic homes. We're trying to figure out what are easy ways to deal with these problems. And I will stop there. And I think we have probably maybe 1 minute, possibly two, to answer any questions. And I'll hand over to Armando, who is hopefully tracking the Q&A.
Yeah, definitely. Thanks, Ian. A lot to chew on there. Really great stuff, and invite all y'all to look at that report when we have a link for you available. There are a couple questions here. Robert Nierenberg is asking, does your $2,500 panel upgrade cost take into account replacing standard breakers with AFCI and or GFCI for older panels?
The short answer is yes. There's a huge range in panel replacement costs, and whether you're using GFCI breakers or not is one of them, because they are substantially more expensive. But the ranging cost is, we've seen costs of $1,000 or less, all the way up to $5,000 to $10,000. Depends a lot on where you live. Depends a lot on how many extra circuits you're adding. Depends a lot on things like, does your local utility require you to move the whole panel, which means you've now got to replace downspouts and things like that because of corner clearances. There's a whole world of things that drive the cost all over the place that are nothing to do with the fact you're electrifying the home, but have to do with the regulation of things like how panels are placed and how they're installed.
That makes sense. Thanks, Ian. Another question from Seth Nelson. Why do you wish to emphasize low power and or 120-volt devices? Is there a significant difference in stress on the grid by installing 1,000-watt heat pumps rather than 3,000-watt heat pump? I see fan power and zoning advantages to multiple smaller units, but I have the impression that most existing homes are built with central AC, and distributed systems are a less direct retrofit.
So there's a few questions there. I'll answer the first one first. So the short answer is yes. One of the things we really, really want to do is to limit the peak power that a home draws, because that's what leads to needing more power plants, adding lots more wires, replacing all the transformers. And those costs are huge on a per home basis, at least as much as any of the work that we're talking about here. And as ratepayers for utilities, we're going to get charged for that. There's no way around it, right? And that we're looking, into keep making sure that people's bills in the future aren't enormous. And they will be if we have to basically double the current electric grid. And we absolutely have to avoid that. That's why we like low power. It also avoids the instantaneous upfront costs if we really want to avoid panel upgrades and the costs and the project delays associated with replacing service drops.